Alright, in this video we are going to talk about the continuity and the discontinuity. Okay, so I got this from one of my math colleague and from the internet, so I forgot who started this and passing on to me. I do some editing and let's share the knowledge. So continuity versus the discontinuity. In class, we mentioned about what makes a function continuous. That means a function are predictable, and you can see there are no breaks in the graph, and there's no holes, no jumps. Seeing is believing. So when we talk about that, you're going to look at the picture. Do you see any breaks? Do you see any open value that x cannot equal to or u should equal y? Do you see any asymptote? The vertical asymptote, okay? So this will be the function made that smooth. Then we say it's a continuous function. Now, picture is very simple. When there is a picture, the answer is in the picture. So if you can chase the graph of a continuous function without lifting your pencil from left to right, that function is continuous. So which means we don't see any open holes, no gap, no break, no jump, okay? And then we talk about the mathematically, we bring back the definition about the limit notation. So as you can see here, the limit, LIM, technically it's my y value, my outcome. In class, we mentioned about the x, domain x, gets closer and closer to a value c. The arrow tells you it's not there yet, but I'm getting closer and closer, so hence I can predict my outcome y, aka my limit. And that's the fancy way to see. Then we talk about polynomial function and rational function. Polynomial function that will be continuous, which means from negative infinity to positive infinity. But the rational function, we get to watch out case by case. Why? Because the rational function has a denominator, so we had to watch out for the denominator. Cannot equal to 0. Therefore, we got to watch out for its special domain. So again, we got to look for the picture or do the algebra calculation. Watch out for the denominator. Then we always want to be fancy. Can you give me the open interval, aka the domain, the x value from where to where? You know the function is continuous, okay? Then we say that when there is a picture, the answer is in the picture. So as you can see, polynomial function, poly, many terms. So you know that by definition, all continuous, right? So from negative infinity to positive infinity. Then rational function, you know that I see the trouble. The denominator, we don't like the denominator equal to 0. So therefore, you will see the first one, you know that, Ms. Ong, I see that. There are two pieces of the graph, right? So I should have a hiccup. And you also see there is a hole, there is a circle when x equal to 1. So therefore, we say that be fancy. The first graph, it is continuous on two parts. U stands for together, the union. So the left piece of the graph will be that domain, aka my x value from small to big, it's negative infinity to 0. And my right side of the graph will be from 0 to positive infinity. How about the second graph? Well, as we point out the denominator, x minus 1 cannot equal to 0, aka x cannot equal to 1. So I know the hiccup is at x equal to 1. So again, you got two pieces. On the left side will be from negative infinite to 1, and together with the other part on the right side, 1 to positive infinity. Love it. When there is a picture, the answer is in the picture. Now, when you think about that, Ms. O said that when there is a picture, the answer is in the picture. That's so true. So if we talk about in classroom, say that, now you may say that, Ms. O, it's a rational function. You told us that I got to watch out for the denominator, so there will be some forbidden number, right? But why the first one is negative infinity to positive infinity? Well, look at the picture. Do you see the picture is very smooth? And you don't need to lift your pencil up, so therefore seeing is believing. x can be all values. When there is a x, there is a y. So it is continued on all my number line. But seeing is believing. On the second graph, you know that my graph shows me 3 pieces. So therefore, I see with my eagle eye, -1 and 1 is my boo-boo. So therefore, I should have 3 chunks of my interval. The left one will be -infinity to -1. The middle one, the U-shape down, it's only from -1 to 1. And the right part will be from 1 to positive infinity. Now, we mentioned about the open interval. The parentheses indicate that number is not there. Can get closer and closer to it, but can never ever be that particular number, okay? All right, moving on. Piecewise functions, you know that. Well, piecewise function tells me there should be pieces, right? Chunks by chunks, right? So if I grab that, ooh, what do I see? Smooth. From left to right, it's very smooth. There's no gap, no jump, no hole. So therefore, my answer key should be -infinity to positive infinity. Now you may say that, Mazon, then how about algebra? Well, you do know that the 2 will be my critical point. Then you're going to verify, can x equal to 2? Yes, you do see x can equal to 2. When I plug 2 in, I do have a perfect answer from both functions there, right? So therefore, seeing is believing, it is a continuous function on the entire number line. Then we talk about that. If you know about the continuity, then what will be the opposite? Discontinuity. So anywhere you see the function is not continuous, aka I see the break, I see the holes, I see the jumps, I see the gaps. So this tells you when there is a picture, the answer is in the picture. So most of the time we mention about the point, kind of like what we talk about the hole, right? And when we say the infinite discontinuity, most of the time there will be a gap. You will see the vertical asymptote. And therefore, the last one will be the jump. So you kind of can predict my function goes up, right, for the next x value, but you drop down. So therefore, that's what we say. When there is a picture, the answer is in the picture. Now moving on, there are 2 types of the discontinuous. Removable, aka you will see there is a hole in the graph, and the other one will be the non-removable, which we say there is a break, there is a gap, or the vertical asymptote. How cool is that? So when we do those, you can neither get from the graph, what you see is what you got, or we can show off. And we're going to get to the algebraic problem. So bottom line, when there is a picture, the answer is in the picture. So smile. So recap, removable, the hole in the graph, right? And it often comes from the cancellation from the denominator and the numerator. You got something, you temporarily remove, take it away. And the gap, right? The jump, right? Non-removable. And then that's what we say. When there is a picture, the answer is in the picture. Now let's move on to the show off. Discontinuity example. Again, it's a show off, no calculator. So when you take a look at that, find the intervals, which means I'm going to figure out the domain from x value from where to where. Okay, so remember, we are math people. We do not like the denominator, okay? So step 1, I know I can do some factoring. So step 1, I can break the denominator as 2 factors. Now use your eagle eye. What do you see? Top and bottom, they have the x plus 2 can cancel out. Now here comes the knowledge. When I cancel out, I temporarily remove. So therefore, I will just left 1 over x minus 5. Yes, it's a rational function. We do not like the denominator. Denominator x minus 5 cannot equal to 0. So when I solve that, you do know that I should have a 2 thing I need to watch about. Watch. One is the x plus 2, top and bottom, I cancel out. So I temporarily take it away. So that x equal to -2, it's my removable discontinue. And the x minus 5, I cannot do anything about that. It's still my denominator, so I just need to watch out for that. X cannot equal to 5, and that is my non-removable discontinuity. So the vertical asymptote, when we graph that, you will see that nicely. Those will be the two hip gaps in the picture, okay? All right, moving on. If you say that, oh, look at that. What do I see? When there is a picture, the answer is in the picture. So what do you see about that? Oh, you can say that, oh, I see the vertical line again at the 5, x equal to 5. You do see that, right? Now, you may say that, then how about a -2? Okay, remember the -2? It's an open circle. It's my removable. So what you see, it's what you got there. You shall see 3 parts. One is from the left side, -infinity to -2. Remember earlier we mentioned about the -2 is my removable. And therefore you see the middle part from -2 to 5. And the last part will be on the right side, from 5 to positive infinity. Once again, when there is a picture, the answer is in the picture. Okay, loving it. All right, piecewise function. So what do we say? We talk about the limit, aka it's my y value. I do want to talk about the 2, as you see already from the given condition. The first equation is x less than or equal to 2, and the second equation is x, the domain, is bigger than 2. So you have a feeling 2 must be my trouble, okay? Since we mentioned about 2, it's my x value. When we talk about the limit, okay, aka it's my y value as an outcome. So we got to look for the 2 at the location from the left side. In class, I mentioned about the on top on the right side corner. Negative means coming from the left side. And the 2 plus means coming from the right side. So what will be my outcome, aka my limit? So when you plug it in, you can say that when I plug it in from the left side, which means less than 2, okay? So I had to use the first equation, aka -2x. When I plug it in, I got -2 times 2. That is equal to -4. Got it? Well, the limit of the function as x gets closer and closer to 2, but from the right side. So which means from the right side of 2 will be bigger than 2. So I need to pick the second equation, which means I'm going to use the function x squared minus 4x plus 1. When I plug in 2 in, after the housekeeping, I got -3. So that's what we mentioned about, wow, the first one is from the left side. I got -4. The second one I got is -3. What do you notice? The left side and the right side, they are not the same. So which that tells me there will be a boo-boo. There will be a gap or a jump, right? So now when you take a look at this one, you kind of can see that Maison said that when there is a picture, the answer is in the picture. So what you see is what you got. When you grab this function, you do know that, oh, I see 2 pieces of the function. And yes, I see there is a jump from left to right. The left side is -infinity to 2. It's okay because the function tells me I can equal to 2 from the first equation, so that would be a bracket. But how about the right side graph? You see an open circle, so that will be a parenthesis, indicate the 2 is not on my right side graph. And that's what we say, cool. When there is a picture, the answer is in the picture. Good? All right, moving on. Discontinue example. In classroom, we continue to talk about those fancy way to show off our algebra. And yes, indeed, no calculator. we're going to identify what will be the removable. Recall, removable will be a whole, aka you can do algebra. When you can factor out and you can cancel out. When you cancel, that will be removable. And those, you cannot do anything about that. It will be the non-removable. And what do we say? Those functions are called the rational functions. So where's the trouble coming from? The denominator. So let's go. Let's see. So again, the first example, you know that, hey, first, I don't like denominator. So I know that some boo-boo is going to happen. So we do the factoring top and bottom. I can do the factoring on top and the bottom too. Well, seeing is believing. Since x plus 1, I can cancel out. So that x plus 1 equal to 0, it's my removable because I can cancel out temporary, take it out, okay? So that tells me negative 1, it's my removable, discontinue, okay? Cancel out. Then what do I left as the denominator, which will be x minus 6. So this is tells me x minus 6. I cannot do anything about that. So that will be unremovable. So that's how we get that two types, separate. Moving on. As you can see, factoring, top and bottom. Can I do something factoring to simplify? Yes, indeed. Activate your ego eye. What do you see they have in common? They can cancel out. Yes. Once you can cancel out, that is the removable. Okay, so x equal to negative 9 is the removable, discontinuity. And the remaining x equal to 9 is the non-removable. Cool, right? No calculator. We are amazing. Moving on. Okay, we got to do the same thing. Factoring. So top and bottom, we can do the factoring. So now you can see that, cancel out. That it's a removable. That will be a whole. I temporarily remove it. And x equal to 5, it's my removable. And the x plus 5, still my denominator. I cannot do anything about that, but I know x equal to negative 5, it's not doable. So therefore, that will be the non-removable, discontinue. Okay, how about this one? Same thing. Denominator is my trouble, but we can simplify by factoring. So when I do the factoring, I got top and bottom can cancel out the x plus 2. Cancel out. Removable. So x equal to negative 2, it's my removable, discontinuity. And yes, indeed, x equal to 4, it's my non-removable. So what do we try to show off? It is the fun thing about math. We do not need a calculator, okay? But we do need algebra. We do need to show off the factoring and simplify. So as a conclusion, continuous function has no breaks, no gap, no holes, and no jumps. If we can evaluate and limit any limit, aka the y value, okay, the limit, the y outcome value on the function using only the substitution method, then the function is continuous. So when you see a graph, if you can trace the entire graph from left to right without lifting your pencil, the function is smooth. The graph is continuous, okay? Now, on the opposite, discontinue, that means it's a point at which the function is not continuous. So activate your ego eye. There is the forbidden number, okay, denominator, right? That caused the trouble. I need to watch out. And there are two types of the discontinuous, which will be removable, aka there is a hole, and we say removable, temporary, I take it out. So that will be something in algebra I can cancel out. And the opposite, the other one will be the non-removable. We mentioned about that will be the location at the vertical asymptote. Remember, asymptote. Activate the ego eye. Where is my invisible line, okay, to cut the graph in 2 parts or 3 parts, okay? All right, and then again, we share this from the internet, and thank you for sharing. All right, have a wonderful day. Thanks.